This is a video to show you two different things. One, how to use the Espotek Labrador to better understand pulse width modulation and how pulse width modulation can drive a servo. And then it also is intended to show you how to control a servo and how to use the multi-servo code to control. In this case, it'll be one servo, but you could control up to 6 servos in a similar manner. So going through the windows on the screen, let's start in the bottom right-hand corner. You can see the equivalent of an Arduino Uno, which is the Adafruit Metro right here. And then we've got the Espotek Labrador. It is a electronics multi-purpose tool. First, I would recommend getting a digital multimeter, one of decent quality, probably costing $30 or $40. But the next purchase, if you don't have a lot to purchase for your test equipment, I would get the Espotek Labrador. It runs around $49. However, it has an oscilloscope, a digital multimeter as well, frequency generator. It is of great value, and I highly recommend it. And so then we have the terminal window up here, and you can see that I've just run make flash, and I'm in the multi-servo directory, ran make flash, so that loaded the code onto the Uno. And then all the way around, we've got this window here, which is the terminal, and I'll go ahead and just clean it up. And so it shows you a prompt, which is inner servo and angle. And so in this case, I have, let me walk through the wiring diagram here. From the Uno, I have digital pin 3 connected to the control pin on the micro servo. And this is the micro servo here. It's from Adafruit. It also is a micro servo with a feedback wire, which is this white wire here. And that's connected to A0. So that will provide an analog signal, which we can convert to digital and will help us understand where the servo is positioned. And then we have the brown and red wires, which are power and ground to the servo. And that's being driven from the small power supply that's also on the Labrador. And then I'm looking at the control signal via the oscilloscope channel right here. And so we'll be able to see that on the Labrador when I bring it up. So that's the electronics part of it. And if I were to say, since I'm on pin 3, I've set that up as servo 1. So if I enter a 1 and a 0, it says 1, 0. Now it was already at 0, so it's not going to move. So we'll go 1 space 1 8 0. And you can see it moved all the way around to the 180 degree spot. And you can also take a look at the window, and it tells us the pulse width, which is a number of 15, or if when we went to 180, it was 72. And then it shows us the servo position, 105 and 490. Okay, so let's bring up the Labrador. So I'll do that, and it will open the Labrador. And here it is. Okay, so the first thing, we've got a signal. That's good. But we're going to have to make some changes. So we already have a signal. So if you're not seeing a signal, so you've got a blank screen, looks like this, make sure that you have the oscilloscope channel 1 up there at the top. It's clicked. We also want to make sure that we trigger. And so it's triggering there. Now we also want to see the top of the signal. Gives us a better idea. So we'll change V max. We'll change it to 5 volts, and we'll add a delay. In this case, I'm going to add a delay of about 40 milliseconds. So it's 40 and then a small m, and that moves the signal over so that we're able to see it. So now we have a window or a view into what that pulse looks like. And this is the pulse for the 180 degrees. Now, if you've read the entry on servos, you know that 1, the servo can only go to 180 degrees. That's the maximum angle. 2, typically that's around a 2.3 millisecond pulse. And so we'll measure it here in a second. And it needs to be delivered around 50 hertz. And we're seeing right here, it says F equals 52 hertz. So that's that's why it's working. Everything's looking good. Let's go ahead and measure it. And so to do that, I right click on one side of this, the pulse, and then I drag the cursor over, and it's 2.28 milliseconds. Can't get much closer to 2.3. So that's the pulse that is driving the servo. Now, one thing we could also do, we could say, what if we said, maybe this will help us understand a little bit better, if we said this was 100 milliseconds. Now you can see that there's multiple pulses that are occurring, and they're occurring at this 52 hertz. So if we measure from the start to here, it shows us the frequency right up here is 51.35. I'm off a little bit. It's actually says it's 52.1. So these pulses are happening 50 times a second. That's 50 hertz. And the width of the pulse, so let's go ahead and make it small again. The width of the pulse is 2.3 milliseconds. This is how you're driving a servo. You have to deliver a signal in between 40 times to 80 times a second, and then the width will tell us where to move the servo. And so if I want to go back to this and say servo 1, 0 degrees, so you can see it says servo 1, 0, pulse width of 15, servo position 106, and you also saw the servo moved. And see, now you can see that the servo pulse width is far narrower. Let me get rid of these. I'll do it again. And it's right at 0.5 milliseconds. And we know that in order to go to 0, we need to deliver a pulse at 0.5 milliseconds. And once again, I'll show that it's occurring many times, 50 times a second. In this case, it looks like it's 57. The good news is the frequency isn't critical as much as the pulse width is critical, and the frequency is not critical as long as it's between 40 and 80 kilohertz, 40 and 80 hertz. And so that's how one controls a servo with the width of the pulse. And if I do one more, let me show you one more, and we'll go pulse width 1, and I'll just go 90. It's going to be about half, it's going to be in between what we saw, and it'll be 1.37 milliseconds. So that's halfway in between 0.5 and 2.3 is 1.37. Actually, 1.4 would be halfway. And it's being delivered at 54 hertz. So that's how you use the Labrador. You got to make sure that you have the oscilloscope channel is checked, the trigger is checked. You're triggering off a voltage. Typically over 3 volts is good. Your Vmax is 5 volts. You've got a time window that's a little bit bigger than the pulse. In this case, I'm going 10 milliseconds. And then you might need to add a delay to move the pulse over. And so if I take that delay out, it's going to move it all the way to the left, and you can't see all of it. And if I add, a bit more, 60 milliseconds, it's going to move it over towards more the center of the screen. So that's the combination of understanding how to use the Espotek Labrador to understand how to drive a servo using pulse width modulation.